So hello everybody, this is our C++ committee Q&A. So I'll just reintroduce myself for anybody who didn't catch my talk earlier. I am Bryce Adelstein Lelbach. I work at NVIDIA, where I am a principal architect. I work on our HPC and quantum programming models and our C++ compilers and C++ libraries. And I head up a lot of our standards work and open source work and that sort of space. And I'm the chair of the C++ committee's Library Evolution group, which is the group that is responsible for designing new features and changes to the C++ standard library. We've also got Zach here, who I will let introduce himself.
Yeah, I'm Zach Laine, and I've been on the committee for, I think, about 6 years now. And I work mostly in the library evolution stuff with Bryce. I do a little bit of work in the room that does language evolution. One of the things that I'm involved with most closely that's like sort of its own thing is there's a part of the committee that's around standardizing Unicode stuff, which is not particularly interesting, but something that like I think we need in C and C++ because those are the only major production languages with no story for Unicode. So. I'm a two-time Boost author, and I used to work at NVIDIA, so I have a lot of background in graphics. I don't do it anymore. So, yeah.
And where do you work now?
Oh yeah, right. So I work at Cadence Design Systems, which is one of the biggest C++ programming outfits you've never heard of. Like if you're outside the EDA industry, which is the industry that designs circuits and chips, like you've never heard of that company. You might have heard of Synopsys because they make like they make some static analysis tool. I forget which one. But anyway, so we're the other one. There's two big players, and we have about 3,000 C++ programmers. So it's a big company.
All right. So what we're going to do is I got a couple of sort of pre-seeded questions that I drafted up earlier, and we'll sort of go through those until folks here feel confident enough to ask us questions. But if you have questions already right now, we can I prefer to start with your questions instead of ones that I made up.
Yeah, and by the way, at any point, if we're answering a question, if we're like expounding about whatever, if you want to jump in and ask, like raise your hand, shout it out, it doesn't matter, right? It's not a big group of people. It's not going to get off the rails if people are just participating, so.
Yeah, in the back there.
I have a question.
Oh yeah, and yeah, please do wait for the mic so it shows up on the video better.
So I have a question. I think these days people are starting comparing the C++ with the new language Rust. Many features are compared, the performance are compared. Any comments on that? And what is the things you think you can do on the C++ side to basically keep competitive comparing with this new language?
Well, so I think that Rust is it is a fundamentally different kind of programming language, fundamental enough that you can't really reuse anything from C++ in Rust. Like everything has to be done the Rust way. And the reason for that is that the whole point of Rust is a whole class of errors you don't have to worry about if you use Rust, a whole class of memory errors in particular. And C++ doesn't have that kind of protection for you. So if you can import a whole C++ library essentially, and then use it as a foreign interface in Rust. But then you're getting rid of all the Rusty business that you're there for to begin with, right? I mean, that's the whole point of Rust is I don't have to worry about those things, but now I do again because I want to use C++. So, we're still writing new COBOL and new Fortran every day, right? Someone right now is writing Fortran as we have this conversation. So C++ is not going to go away. The question is how much will the Rust niche grow and how much will the C++ niche shrink? And that's the real question. And I think that if we're doing our job correctly on the standards committee, if we're doing our job correctly as C++ programmers, C++ is going to be a very viable language in many areas, especially high performance stuff, HPC, 3D graphics, whatever. Anything that you require performance for, C++ is going to be the dominant language for many years to come because of the installed code base that exists.
Yeah. Yeah, I would say probably the best feature or the best part of C++ is its existing ecosystem and the ubiquity of tools and support for C++ across almost every platform. you know, if you look at like C++ as a language, like, you know, it has some warts. But there's a lot to be said for, you know, for inertia and for ecosystem. And the C++ code that we have today isn't, you know, going anywhere. And yeah, you know, you mentioned Rust, but the other thing that we've seen in the last year or so has been the launch of a bunch of these C++ successor projects. There's Carbon, which is a language that aims to be a successor language to C++ that is designed sort of from the ground up to be compatible with C++ so that you can mix Carbon and C++ source files, and that you can pass C++ classes and functions into Carbon code, etc. There's also CPP2 from Herb Sutter, which is sort of an initiative that has maybe similar goals but takes a different approach of sort of inventing a new syntax and a new front end almost for C++. And there's a few other, you know, projects and efforts here. There's the Circle compiler from Sean Baxter, which is just trying to explore how we can just evolve the C++ language sort of outside of the standard in exciting new ways. And I think what all of these have in common is that they're trying to retain that sort of interoperability with C++. That they're not trying to be like a new from scratch, like if we could redesign the world and everything was perfect, here's what it would look like. They're trying to be like, okay, well, how much can we improve on C++ yet still be able to work with the existing code that we have? I would say that if you think you can use Rust for, you know, a project, it's probably not a bad idea to explore that. Yeah. It has a lot of, like if I was writing something from scratch, I would probably prefer to do something in a language like Rust if I could. It's just a question of, you know, am I really ever going to be able to write something completely from scratch where I'm not going to have to work with any existing code or any, you know, existing C++ libraries, et cetera.
Yeah, so in the team that I work in, we maintain a framework for running distributed jobs for lots of other teams that might need to do distributed work. And so we have a bunch of individual little applications that are talking to each other that are distributed themselves and running on a network. So we have one guy that writes everything in Golang. We have one guy that writes everything in Rust. We have most of us writing stuff in C++. So there's definitely a place for Rust and C++ to coexist, and there's nothing wrong with doing that. I think that as soon as you try to make that on the library level, that's where you run into problems. But having Rust code around is, you know, it's usually a great idea. The guy that writes the Rust code really likes writing it, and, you know, he has a low defect rate because he's using Rust, and that's great.
The only real problem that I think Rust is starting to face is Rust has adopted this model of like we build everything from source and we build it from source each time. Mm-hmm. And as the Rust ecosystem is starting to grow and as bigger and bigger projects are starting to be developed in Rust, we're starting to see the Rust community be like, hey, this like, you know, builds are getting kind of slow. Yeah. And also, you know, while I think we're here at a Linux Foundation event, obviously all of us here are pretty big on open source. The reality is there is proprietary software out there for a variety of reasons, you know, and sometimes we just have no control over that. And that doesn't really fit into the Rust ecosystem as nicely as we'd like. So I suspect that at some point in the next few years that Rust will have to address this and we'll have to add some form of support for binary distribution and binary builds. But that's really challenging because being able to build from source and being able to look through everything that you're calling is very important to their sort of safety model. Yeah.
Any other questions?
Thank you. I do have a few other questions, but if you guys feel I'm taking too much time, just let me know, okay? So one of the questions I have is that I've been doing the C++ coding since I joined the university. So I'm really comfortable for doing that. All my projects in C++, but But I found that with new features, more and more features adding into the new standard released every year, the learning curve of this language is getting much, much higher, I feel, than it used to be. So it's kind of frustrating for me to try to teach or educate new developers on the team to learn this language. This language is really powerful, and that means for the new programmers, they usually shoot themselves in their foot. So any suggestions or tips or helps that can basically making the new programmers easier to use this kind of a really advanced language?
So there used to be a kind of cottage industry of teaching C++, and it was mostly in the form of writing books, right? So 20 years ago, when you had exceptional C++, more exceptional C++, that series from Herb Sutter, you had the C++ gotchas. There are all these titles like that. There were how you use C++ well, how you avoid common pitfalls and stuff like that. No one's really writing books like that anymore because no one's really buying books anymore, right? So everyone is looking at CPP reference, which is great, but it's reference material, it's not tutorial material. So there exists this gap between a new language feature and understanding the specification of it. That's there, right? You can either read the standard, or you can read CPP reference, which is essentially a plain English version of the standard. But there's a gap in the middle there for understanding why would you use this? What's the reason to use this? What are the use cases for and against? And right now that exists in the form of people's blogs and stuff, and it's all distributed. There's no one place you can look, and there's not definitive sources. Sometimes the blogs are saying contradictory things. The same blog over time is saying different things. So I don't have a good answer for that. I think maybe the answer is we have a new section of CPP references. That's where everyone lives most of their C++ introspection time anyway, where you have that tutorial kind of content.
Yeah, so one of the feedbacks I got from a new engineer is that I asked him where he learns to do the programming. He told me I use Overflow.
Sorry, he uses what?
No. What's that? The online forum.
Stack Overflow.
Stack
Overflow.
Yeah.
Okay.
So, but I check the articles there. Many of the articles there actually are obsolete or even containing wrong information.
Yeah.
So many of the answers there are actually misleading. If for example, the C++ committee can gather the information, organize something to basically have verified information for people to learn, I think that will greatly help those newcomers.
So here's the thing about the committee that a lot of people don't understand from the outside. It's an open source software project. So if you were to go to someone at the Mozilla project and say, I don't like this way the browser works, they'd be like, cool. So are you fixing it or what? So unfortunately, because it's an open source software project, unless you're going to fix it, it's not going to get fixed. It relies on volunteers wanting to get stuff done, and most of the volunteers who are involved in the C++ standard process are involved in writing papers because what the committee produces is PDFs, and PDFs of the C++ spec, not PDFs of almost not PDFs of anything else. Occasionally there's another kind of PDF, but so what I'm getting at is that those kind of things have to come from the community at large, unfortunately. The committee just doesn't have time even to do all the committee stuff we want to do, and so people get there, but slowly. The dissemination of that information is very slow and very imperfect. And I wish there was a better story for it, but most C++ programmers are really busy and don't want to write documentation. I don't understand why CPP reference is a thing. It's great that it exists, but it's kind of a mystery to me how it got started and how it gets maintained. But we need someone to do something like that for that kind of tutorial level information. Yeah. I think you're very much right, but that's not something the committee can solve, unfortunately.
Thank you.
It's tricky because I think if you look at a language like Python, Python's got a big foundation that has lots of resources and staff, and they have people that are on staff that do things like produce that tutorial content that have that as a job. And the C++ we do have a foundation, and it's just the scope of its operations are smaller and its resources are more limited. There is some introductory material like that's on the C++ Foundation website, but the problem is it's outdated. It's probably 10 years out of date. And that's really the challenge, is that you can't just produce that content once. You have to produce it, and then you have to keep it up to date. Yeah. But I would also say on just the question of how do you teach C++? Well, don't teach all of it. That's probably not a wise idea. I think
step 0 is you pick the subset you want to teach.
Yeah.
Right? That's the important step 0.
Yeah, there's like a lot of, if you're in a code base where you can mostly like write modern C++, there's a lot of like legacy things that it's probably not that important for folks to know how that works. I think there's some in the C++ community that say like, oh, you should like never teach pointers. I think that's maybe a step too far, even if they're going to be used pretty rarely in modern code. Like that's still a thing that people should know. But like built-in arrays, like built-in C-style arrays are like really weird, and they have all these caveats, like you can't return them from a function, and they have this weird decay to pointer thing. Like you could just not teach people that. You could just be like just don't use this weird thing.
Yeah.
Just like use std array, and like that would just make life like easier for a newcomer to the language.
Yeah, and I think so. For your purposes, though, to answer your question and your situation, I think the right answer is almost always going to be find the pain points that the more junior developers are experiencing and show them how a new language feature like scratches that itch or solves that pain, right? That's how you teach that feature to someone. And it's not 100% this way, but the vast majority of new features that we add to the language itself are designed to regularize the syntax or make it easy to do something that you can do right now, but it's much more verbose the way you do it right now, right? Yeah. So make something more terse and expressive in its form, or to make it more regular with the rest of the language in its form. So that does lend itself to teaching things in a simpler way. Like, this is the old way we used to do it. Like, forget that code. You need to learn how to recognize that code and understand what it does, but always write it this new way. And the reason you write that new way is like you can see A/B comparisons of like the old way is not as good as the new way. And this is something you see in committee papers. There's things called Tony tables, because this guy in the committee named Tony is always like, you need to show me the before and after. If I don't see the before and after, I don't know what I'm reading. So there's all these Tony tables of like, this is the way the code used to look. With my paper, it looks like this, right?
Yeah.
And if you kind of look for those in fact, he has a really nice GitHub called CPP17 in Tony tables, which is the entire, like every single language feature and library edition. And he's got before and after 14 and 17. I think he did the same thing for 20.
Yeah.
Yeah.
And I mean, another good resource, Zach mentioned we've sort of passed the golden age of programming language books. But there's, 15 years ago, there was like 1 or 2 C++ conferences. Now there's a ton of C++ conferences. And now they all produce content that goes on YouTube and that's recorded with pretty high quality. And I know for a lot of people, that's their go-to learning material. Go look at, for almost any new feature, somebody's going to give a talk at some C++ conference about it, and so you can go find the ones that are best, and point your folks at those, or send your junior developers to conferences, which is a great way for them to network and learn and build connections with the community.
Thank you.
Any other questions? Oh, we got a question up here.
I want to know, how often does the language working group give credence to, compile time costs when it comes to introducing a new language feature? I know earlier you mentioned a standard array. Even that versus a raw C-style array is a template instantiation versus the not.
I would say, putting on my hat as compiler vendor and also being familiar with what the other compiler vendors on the committee do and say and feel. Implementers are often concerned about compilation speed. It's not always expressed that way. Usually what their concern is like implementation complexity, like how challenging is this going to be to implement. And it tends to be that if a language feature is going to be introduce a ton of complexity, that can usually be not great for compile time. When Concepts was in its multi-decade saga of development, at various points in time, design changes were made because implementers had pointed out that, if we do it this way, it's going to add additional complexity. It's going to be very hard to implement those checks. And in one case, in one of the later iterations of concepts, there was a particular mechanism that we sort of knew would lead to this quadratic, it would sort of take quadratic time to be able to do these checks. I don't remember whether we actually decided to not do that thing, but it's certainly a concern that I think comes up. In particular, these days, we think about it a lot when we're thinking about const-expr, like compile time facilities. How expensive are those going to be to implement?
Yeah, so there was at least one language feature I can think of in the last few years that has changed because of this concern, and that is the static compile time reflection, right? So compile time reflection, there's a bunch of different ways you can do it. One way that someone suggested doing it is essentially we make a bunch of things that work like the standard traits, except that they give you introspection into the code. So we basically spell everything the same. That is not the way that people want to do things because they want metaprogramming, they just don't want all the angle brackets that we have in metaprogramming now, right? But there was a major concern that was raised by one of the vendors who said, like, look, if you do that and I have to instantiate a template for every node in AST, that's going to explode the compile times, and like no one's going to want to use that facility for metaprogramming. I think on the library side, you see a little bit less of that because you tend to see a lot of stuff that's, basically everything's a template, like most new interfaces that get introduced are supposed to be generic. There are some cases where we have like sort of fundamental building blocks that are templates that don't need to be, like stood forward. You don't need to write stood forward. You can just do a C-style cast, T-ref, that's what I do all the time, right? And that saves you a template instantiation in that place. And if you have that in a hot loop in your template instantiation stack, then that saves a lot of compile time. But the single biggest thing in typical C++ code, that is non-metaprogramming heavy C++ code, the biggest thing that you pay for is inclusion time. And you can show that like even just including a standard header like has a measurable time in seconds often, right? It's like a very long upfront cost to then get to do the real work of the compilation. So like going to 100% modules will give you 10x speed up, and again, non-metaprogramming heavy code based on independent analyses from Microsoft and Google using completely different technologies for doing modules. So they found that like modularizing a certain subset of their code that they were exercising gave them about a 2x speed up. So like let's say 1 in 10 TUs in the Google case, but those TUs were very regular code that was being generated. They made modules for those, and they got a 2x speed up on their whole build. And then they extrapolated that to 10x, and Microsoft did almost exact same experiment with a different subset of headers, generated a different way, different module technology. So what I'm getting at is if you have super metaprogramming heavy code, there's no way to get away from those template instantiations. And in fact, const-expr or function-based metaprogramming, non-const-expr function-based metaprogramming can sometimes be even more expensive. It's just expensive to do right now. Hopefully, we'll get a metaprogramming system and I just said the term and I can't think of it anymore. Reflection system that is fast to compile time. But for now, the biggest win you're going to get is by modularizing your stuff as much as possible as soon as you have access to a build chain and a compiler that supports modules, which I know we're not there yet, but it's coming.
So for anyone who may not be familiar with modules, modules is a new system that was added in C++ 20 for organizing C++ code and translation units, and it's non-textual as opposed to headers, which just textually include the whole thing. And one of the subtle big wins with modules is that the cost of including a module is, or the cost of importing a module is not a linear function of its size. So in C++ 23, we added a standard library module, and we just added one. There's one module for the entire standard library, and you might think, well, that sucks. Previously I could include just the headers that I need. Now I have to import everything. But the way that all the module implementations work is that the module that gets built, it has this index of all the entities in it, and when you go in and use something from that module, it goes and looks up, this, std vector, oh, it's in this location in the module file, I'm going to go load it up now lazily instead of loading it all at the same time. And so when we were adding the standard library module, we did some performance evaluation of this, and replacing very granular standard library includes with a single import std was still faster. So importing the entire std module was still a huge win over just including the headers that you need because it's not textual.
Yeah, I think it was actually like pound include IOStream for Hello World was slower than import std.
Yeah,
right?
yeah.
Just the standard thing that you want to teach to a new programmer as like, this is the way you write Hello World, that's better with like this mega module that includes the whole world of the standard library.
And so I think that has a lot of important implications for how we structure our code. This lazy module inclusion mechanism means that we don't have to if you're in a modular world, you don't need to worry about separating things into very granular headers. You can just sort of make your modules this is a logical, this is all this functionality that I'd want. There are maybe some caveats to that. There may be some circumstances in which you want finer grained modules, but generally I think you'll want pretty coarse modules that represent the actual logical structure of your code.
Yeah. And you're going to get, in some form, you're going to get some kind of modularization of headers for free without making textual changes to headers. But there's still arguments on the discussion list happening right now. Like this week, people have been arguing about the right way to do that. Yeah. So it's not 100% baked, but eventually you'll get this thing in a robust form called, what do we call it?
Include translation.
Well, yeah, I mean that's a way to say it, but there's a term of art that we use, and I'm forgetting right now. Maybe header modules or header something like that. Anyway, so the point is you could just say pound include foo.h, and then if your compiler detects that you could have written import there, you can write import. And if the compiler detects that's okay to do, that part is still being argued about, the right semantics for that. But essentially, you're going to be able to get it to make a fake module out of the stuff in that header, and then make the module, and that's what it imports, and you don't have to write the module, right? So, header units, that's what we call them, header units. So that is going to be a nice bridge, but it's not perfect. For instance, macros in that header will break things, like if the macros turn on and off different parts of the code, right? So.
And that translation, it's the compiler can choose to do it for all your headers, but for the standard library headers, it's I believe it was required. At least at one point it was required
to be header unitable.
Yeah.
Or certain of them.
So I don't know what the compilers are still rolling out their implementations of this, but what that means is that essentially, once your implementation has support for modules, and you'll get the benefits of modules for all your standard library includes without having to do any work. That just any existing includes will get translated. Yeah, and modules will probably be where we'll see the biggest compile time improvements. The only problem is that modules is a feature sort of unlike any other that we've added to C++ since the start of the C++ standard, because it has this really wide ecosystem impact. So something like concepts, all the compilers have to add support for it, and your IDE has to add support for the new syntax, et cetera. But your build system doesn't care about concepts. Or your build system doesn't care about coroutines. But your build system does have to care about things like modules. And there's a whole bunch of other things that have to care about modules. And so I think it'll take a little bit longer until the full stack is really ready to be able to use modules.
Yeah. So we're in the last few minutes at this point. So if anybody has any more questions, it's a good time to take them.
Or we can probably, do you have to rush back? We can probably take a couple.
No? Yeah, I'm fine to go a little bit long if people want to. That's fine too.
Well, I have one more question.
Sure.
And it's related to, does the committee take into account, I guess, the use of certain standard library features, or I guess controversial library features such as streams and exception usage, especially like looking at the game community, that's normally avoided when it comes to making like new library features. So I see a lot of new library features. There's like it takes a lot of like, does this throw an exception, like no accept, or is this potentially throwable into account? And does that take into account to like new proposals?
Yeah.
Yeah, I think so. And in particular, you have a lot of people from the embedded world. You don't have a lot of people from the games industry itself. Like, people from the games industry are there, but they're not in large numbers. We have a large number of embedded folks who are like, yeah, but exceptions aren't a thing in my compiler. Like, I can't even do that. So could we have an interface where I can opt into exceptions or stuff like that? So these discussions are definitely being had, but I think the default position for most people on the committee, though, is exceptions are part of the language, you just got to deal with it. And that attitude kind of ignores the fact that we've got this major use in the form of the game industry of C++ that just never turns on exceptions, right? It's like, you have that off in your compiler. If you're using Green Hills, it doesn't even exist. There's no way to turn on code gen for that in your compiler, right? So that is, I think, a missing piece, and people are really afraid of forking the language by having like a dialect with exceptions and without exceptions. My argument for that is we've already forked the language, you just don't admit that we forked the language, and that's really the problem we're having. So I think there is a desire to square that circle and somehow figure out how we make these two ecosystems work together and play nice with each other. But there's no one that I know of that's really spearheading trying to regularize that and make sense of that. People talk about it a little bit, but you don't see a lot of papers about it. So if that's something you care about, you or someone you work with maybe can get that ball rolling. The C++ committee ultimately is just a filter. You get people submitting papers. Anyone can submit a paper about anything for any reason, and then the committee says yes or no to the papers, and that's all it does, right? So if no one ever, and this is how it's like an open source software project, like I said before, if no one ever brings something up, it doesn't get fixed. If no one ever brings it up and then doesn't get discouraged from initial bad feedback, it doesn't get fixed, and so on.
Yeah.
So
it also means that the committee leadership does not have. It's like the UN. The committee leadership doesn't have an army. They don't have a group of people where they can be like, go do this thing. It's dependent on what proposals get brought to us. But on the question of like exceptions and no accept, I will say that I think the current leadership in library evolution is very much in the exceptions are bad camp. I'm obviously come from an HPC environment and from a GPU environment where we don't have exceptions. And one of my vice chairs, Ben Craig, is sort of he comes from an embedded world, and he's the one who champions the freestanding mode of C++. And so we do have leadership that is at least making sure that when we're looking at new proposals that we are thinking about, have you thought about how this might be used by, freestanding users? Have you thought about how this might be used by people who aren't going to be able to use exceptions? And so I think we've started to see over the past few years a little bit of a culture change in the library evolution group. But the core language group very much has the attitude of exceptions are part of the language. That's what you should use. Yeah. I think we are increasingly we shy away from exceptions as the default error mechanism in library evolution. The one place where this came up recently was the sender's asynchronous framework. That's sort of the big project that we're working on in library evolution. The initial form of it, the way that errors were passed to things was sort of mandated that it would be through an exception punter. And library evolution's like, no, like that's not, we cannot tolerate that. Like it can't require us to pass errors as exceptions. That's just not going to work. And things like expected, which is sort of a library-only approach for being able to return either a value or an error, have been really important to library evolution. there's been, a few efforts over the years to explore, language solutions to this. There's Herb Sutter's proposal for this like lightweight exception handling model, but that's not really had a lot of traction. There have been some proposals to sort of formalize and codify the notion of a no exceptions mode, but as Zach pointed out, there's certain constituency in the committee that's very resistant to anything that they see as creating dialects of the language or sharding the language. But the best thing that you can do if you care about this is to get involved in the committee and to speak up about these things.
All right,
so we are at the official end of the session. So
Right.
I believe that there is lunch if people want food, but we can probably stick around and take, a few more questions if people
Yeah,
have
no,
questions. Oh, okay. We can't do that, but you can come find us in the hallway.
All right, thanks everybody.
Thank you.